How fun is CSS?
Not fun at all. I hate it. Worst language.
Oh yeah,
Oh yeah.
totally.
Good morning, Mateo. Thanks for joining in. We're gonna be doing a lot of cadence today.
Woohoo!
Woohoo! Yes. Something I understand. What's up, Falcon? We're just waiting a few more minutes for everyone to join in. And we're pretty much gonna spend all day today on cadence, so we're not in too much of a rush, and I think we're gonna be able to get this done in an hour for sure, or at least just like a base skeleton of what I want to teach today.
Yeah, and if we do have time left over, I can definitely go over routing on SvelteKit and walk through SvelteKit 1.0 since it launched. Because I've basically built I've rebuilt contract browser using Svelte 1.0,
Oh, really?
and yeah, so I'm really familiar now with how the routing, the server side rendering, how everything works. So
Oh,
we can
wow.
either do it this time if we have time left over, or we can do it next time. But feel free to use up all the time on the cadence part. I think we've spent enough time on Svelte yesterday, like last week.
Okay, yeah, sounds good. Wait, that's awesome though. I guess just like quick feedback, like how was it? Any better? Any worse?
It's good. It's good. It's very similar to like the most recent versions. But once you set things up, for example, Lamford, is building the whole backend for Contract Browser. Big shout out to Lamford, who I know is here. Um, and you know how on Float we basically leak our API keys.
Yeah.
Probably shouldn't be saying this, but you know how we do that
Yeah, yeah,
because
yeah.
everything is front end.
Yes.
By using SvelteKit properly in the backend, what I do is I have a server endpoint on. I basically have a server.js file, right? Okay. I create an API folder, okay, and every route I want in my API, I have a folder, and within that folder, which I name, for example, contracts or search or account, right? And within that folder, within each of those folders, I have a plus server.js file. And that file only runs in the server. So if I
Oh.
put my API keys, they can also be in a .env file for code contributions, right? But if I have my API keys in there, they will never be leaked to the front end.
Wow, that's awesome news. Yeah, no, I
And And the cool thing is, I can make all, and then on the front end part of the code, on the page load, I can just query my own backend, right?
yep.
Without having to query Lamford's backend. So I completely abstract away Lamford's backend. And so it's more secure, it's more performant because it's server side rendered. So all the HTML is already there when you load it. I can better manage the metadata stuff. So all of this to say that as we build mirror.xyz, it's gonna, you know, it's gonna turn out great, and we can always port over those learnings into Float as well.
That is awesome news. Sweet. Um,
But yeah, over to you, Jacob.
yeah, let's do this. So welcome everyone. I think this is the third episode of Build from Scratch. In the first one, we kind of did like an overview, diagram slash like design of what we think, or how we were thinking through architecting the our Memento platform. And in our last session last week, we did an introduction to Svelte. Andrea, taught us Svelte, and taught us some basic stuff about how to make a Svelte dApp or a Svelte project. And so today we're going to be walking through Cadence, and the idea is that if we're all able to learn Cadence together, then next week we can sort of combine the two. So we can take our learnings from Cadence, we can take our learnings from Svelte, like Raven is saying, Sveldance, and we can start making an actual dApp, which again is really just a normal application like Svelte combined with some blockchain code, which is what's giving it that like decentralized name. So just from everyone who's in this chat, I'm pretty sure like 90% of you, if not all of you, already know Cadence because I know that like I can confirm that 80% of you have like, graduated the Cadence Bootcamp. but we're gonna go through this anyway, just because it might be helpful for the people watching the recording, and maybe you'll learn something new today as well. So I'm gonna go ahead and share my screen, and we're gonna walk through sort of like an introduction to Cadence, but I'm gonna make it pretty quick, just for the, like for what we're gonna need in this series, and we're going to start architecting our contract to build this Memento platform. And once we get there, once we get to actually building out some of the resources and stuff like that, I'm definitely going to be looking for some feedback or some input from the chat, so this can be sort of like an interactive experience. So okay, so right now let's spend like 20 minutes, I guess, overviewing Cadence. So we have a contract named Hello World right now. In Cadence, one thing that is very different if you're coming over from other smart contract languages is that the contracts are completely separated from the transaction and script layer. So what we're gonna do is we're first gonna focus on building out a contract, which is essentially a rule book for things to run. It's what data is alive, what data is there, and then then we're going to add some functions to modify, view that code, stuff like that. And then we're going to be able to call those functions from our transaction and script. So let's just code this from scratch, just so I can sort of give you all a little taste of Cadence. So if we wanted to make a variable, let's say we wanted to make or I guess a new piece of data, let's make a variable called greeting, which we're simply going to do just by saying public, let's make it var, so that we can eventually change this greeting, and it's a string type. And then let's add a function called, I don't know, change greeting, that takes in a new greeting, which is a string, and sets self.greeting equal to the new greeting. Now, I went pretty fast, but essentially all this means is we're declaring a new piece of data that is a string type, and then we're adding a function to change that greeting. And this function takes in like a new greeting that we want to set it to, and simply sets self.greeting equal to the new greeting. Now, in our Cadence course, I always get a lot of questions about this self keyword. What self means is it's just referring to the variable at the next layer above it. So this is just saying it's just referring to this variable right here. All right. Now we're going to get this error saying missing initialization of field greeting. The reason for that is because when we deploy our smart contracts, we have to set our data equal to something. The reason for that is because once this contract gets deployed, anyone's going to be able to read into it or call this change greeting function, right? And so if we're not giving greeting a default value, then it's going to break. It's going to be very weird. So we have to give it a value here. Now let's set it equal to, actually, I'll give you all a little test here. Why could I not set it equal to 10? Is there a reason I can't set it equal to 10 here? And try it. Yeah, exactly, Raven. It's a type. So I can't set it equal to 10 because this is a integer or a uint64 or whatever else, but it's essentially a number, and we're asking for a string here. So let me go ahead and delete this and just type in good job, Raven. Boom. And I'm going to deploy this contract. So the cool thing about the Flow Playground, the reason I love it is because we can redeploy this contract, we can change it, we can make a lot of modifications. Just know that in the real world, you can make a lot of updates to Cadence, which is why I prefer it to other languages. For example, I think it's a lot better than Solidity for this reason. Although you can get into the discussion about upgradability in the Ethereum and whatever, but I think that Cadence upgrades are a lot easier. But do note that, for example, when you have contracts in Cadence, you won't be able to add new data and stuff like that. But we can certainly modify some functions. But all this is to say that on the Flow Playground, you can make as many modifications as you want. So it's an awesome testing ground for your contracts. And I always recommend spending as much time as possible on the playground before going to testnet, like I did with Float, and I deployed over, I think, 200 contracts, and my account is now blown up. Um, so let's go ahead and yeah, so we deployed this to account O1 show off, yeah. So I deployed this to account O1, and let's go to a script now. So we want to read some data, right? Now, with a script, we really just have a function called the main function, and we're returning a certain type, and you can see that inside the main function, we just have this little bit of code. Now, this is very simple, right? If we execute this, it's just going to return 1 and the value of it. So what we want to do instead is we want to return the greeting that is inside of this contract. So does anyone have any ideas of like what are some initial things we're going to have to do to this script in order to tell it that we're going to be reading from this hello world contract? Anyone have any ideas here? Yeah, nice, Raven, and great job, Benjamin as well. So we have to import um, hello world up here. From which account? What's the address of the account that we deployed it to? Nice, Raven. Speedy McGee over there. So yes, you're definitely right, Raven. And just to sort of explain this a little bit, contracts in Cadence are deployed to an account, and an account has an address. So in this case, we deployed our Hello World contract to the account with address 0x01. In the real world, addresses look something like this. So I'll just paste this here. The real world addresses look something like this, OX, and then a little bit more numbers. But the playground makes it a lot easier for us. And one other thing I like to note is that in the real world, you can deploy as many contracts to an account as you want, as long as you have enough flow. So this is the Flovatar account. So you can see there's like 6 contracts that are all deployed to one account. However, on the Flow Playground, you can only deploy 1 contract per account, which is not that really a big hindrance, but just something to note in case you were wondering the differences. Um, Raven says, "Finally, I'm right for the first time out of like having life." True, Raven. After all these boot camps and all these courses, you're finally getting it. I'm happy for you. So we import the Hello World contract. Now, what we're gonna do is we're gonna try and read from Hello World. Now, first of all, what should the return type of this be? If we know we're gonna be returning the greeting here, what should the return type be? String. Exactly, Benjamin. Great. So let's put string here. And now we get an error, right? So in order to return a string, we have to somehow read into the hello world contract, and we can do that. We can't just put greeting because this script has no idea what greeting means, but we can put hello world dot greeting. And now the script knows exactly what we're talking about because we're going into the hello world contract and then reading its greeting variable right here. So that's awesome. All right. Perfect. So if we go ahead and we run this script, we're going to get good job, Raven. And it's a string. Exactly as we expected. Pretty cool, right? So let's go back to our transaction here, or let's go to our transaction here, and let's try and make something change. So the difference between a transaction and a script is that a script reads data and a transaction changes data or mutates data. So because we wanted to read our greeting variable, we call the script. But because we want to change the greeting with this function, we have to go ahead and run a transaction. So let's do that together. Let's not talk about the prepare phase for now. Let's go into the execute phase. And let's try and call something. Let's say hello world dot change greeting. And we have to pass in a new greeting here. So what if we wanted to pass in, I don't know, let's change to great job Saint for answering all those questions. So if we were to run this, it doesn't matter what signer we use right now. Send it. All right, it's ready again, so we should be done. And if we go back to our script, now it says, "Great job, Saint." Right, so it changed it. That's awesome. Um, Now, one thing I like to do with transactions is because you really want your transaction code to stay the same, no matter what it's doing. We sort of want to templatize this transaction a little bit, and the way to do that is to take this hard-coded value. Hard-coded just means we're really plugging in the value here and not really, like we're just sort of shoving this value here. What we can do instead is we can get rid of this and change this to param, or let's just change it to like, I don't know, I don't want to name it new greeting, it's kind of confusing. Let's change it to user input, right? And so we can make an argument to the transaction called user input that's a string type. And so what that'll allow you to do, and the playground actually reflects this perfectly, is it brings up a little input now that we can type in some data. And it's going to take that data that we've typed in right here, right? Like, hello there. It's going to take this string, it's going to pass it right here, and then this is going to go down to here and get passed in as the new reading argument. So if we go ahead and run hello there, done, and now it says hello there, right? And the great thing about this is that now we don't have to modify our transaction code at all. We don't have to delete this or whatever. We can simply just type new input into this little input field here. So much, much, much nicer, right? So do we have any questions so far about just basic cadence stuff? And after this, I'm going to spend about probably 10 minutes going over resources, and then we'll start building out the Memento stuff. Yep. Yeah, so far just basic coding stuff.
Yeah, maybe we can start working on Memento and then explain resources as we get to them. What do you think?
Sure, yeah. Yeah, totally fine. So let me go ahead and make this contract name Memento.
Done. Perfect.
Boom. That's
All
it.
right, guys. Thanks for joining.
Yeah. That's it, guys. So we have Memento now. And there's actually a lot we're gonna have to do because first we're gonna have to think about, what stuff exists in our Memento contract. And then we're gonna have to slowly, transition it to an actual NFT based contract that is, allowing you to deposit, withdraw NFTs, mint them, stuff like that. But let's stick with the basic stuff so far. So actually, do we have that diagram, Andrea? I think did we like draw some stuff in there?
Yeah, yeah. Let me see if I still have it. It's in the Discord. It's in the Memento channel. Otherwise, I can start a session. Here, let me start a session and send you the link. 1 second.
Oh, actually, yeah,
Okay.
you're totally right. Yeah,
Oh
here it is.
no. Okay, I
Oh, no
lost it.
worries. I found it. So this was from our first session. And it looks like, oh yeah, okay, I see. So this was from our first session, and this is what we had initially architected our smart contract to be. Now, it might be a little hard to read, but essentially, the idea was that this was the main idea, was inside the smart contract, we had this resource called a post collection and a post. So things that represented the posts of, the written content. So if we go here, let me be able to read chat again. So questions. Um, cool name. Thanks, Adam. So let's go ahead and make a resource here called post. Now, what a resource is you can think of it almost like an asset or an object or something that represents, a real world, object, but in code, right? So one of the, top use cases for a resource so far in the entire blockchain space has been NFTs because it represents, the NFT asset or the NFT, object. And what you can do is inside a resource, you can put in some information about that resource. So, for example, if this were an NFT, we would put in maybe an ID. We would put in, I don't know, like a serial number, right? But in this case, we're going to be doing data for a post. So this is what data do we want to be stored in here that has to do with a post that is made when a user, mints their own blog or their own article or whatever they're minting on the Memento platform. So I believe we had some data here, right? We had the body text, we had a title, we had a date created. So all of these things, let's add into our resource here. So first of all, let's make an ID because that is always, going to be a great thing to have inside of a resource, an ID. Let's also make, I believe we had a title, the string. We also had a body, which is a string. The body is really just like all the text that the user typed in. is published is a Boolean. Let's try and add that. Now, I believe the purpose of this one was to distinguish between a draft and a actual post. And then the original owner address. Now, this is going to represent, actually, we can put this in comments here. This is going to be the original or the address of the original creator. Yeah, the OG, exactly. Okay, cool. And then let's also just for now, we were sort of thinking through an array of authors. For now, let's just do an array of addresses, and we'll modify this later to be more complicated. Okay, so with all that being done, we now have to initialize this stuff. So the ID is actually really easy. What we're going to initialize the ID to is the UUID of the resource. Now, what a UUID means is this is sort of, I think it's officially called a unique identifier. Now, what that does is this is a unique ID across the entire Flow blockchain. So no resource will ever have the same UUID. So this allows us to, we can use this to set it to the ID of the post, which is, it makes it very easy for us because we know it's never going to be duplicated. So honestly, I always do this for my IDs inside of resources, and maybe it's a good pattern for you as well. So we can also pass in a title, the body. We need to pass in the original owner and the authors. All right. So we can go ahead and set the title equal to the title we're passing in, the body, and we're going to set self that is published to false initially, just so that we can give the user the option to, maybe eventually publish it. We're going to say self dot original owner equals the original owner, and then self dot authors equals authors. Right? Cool. So we now have somewhat of a structure going on for our post. Leffert says, now that we already have UUID, why should we set an ID for posts? That's a great question, and I will answer that once we get to the NFT portion of this lesson. But in short, Lanford, it's because when we when we change this to a non-fungible token contract, this is going to have an ID variable, or it won't fit the standard. So cool, we have a resource here. Now let's go ahead and let's make the second resource we had. So Numity says, why are we not passing through the ID? Great question, and that's sort of why I was explaining this right here, is that what we're going to do is set the ID equal to the UUID of the resource. Now, the UUID is something that we don't even create. It's sort of like created for us under the hood. In fact, I can show you that if we were to try and say public let UUID here, it actually wouldn't even let us do this because it says cannot declare a field here UUID, right? And the reason for that is because it already exists. So when you think about a resource, think about the fact that this is already here. We just can't see it, okay? So we're setting the ID equal to the UUID, which is just a unique identifier. Of course, we could pass in the ID here if we wanted to, and we could pass in 1, set it to 1, pass in 2, set it to 2, but it's more interesting and also a lot safer to set it to the UUID because we know it's never going to be duplicated. And especially as we get to NFTs, we're going to want to make sure this ID is forever unique. Cool. So we made a resource called post. Now let's also make a collection, right, of resources called post collection, or just simply collection. Now, yeah, so let's go ahead and do that. So let's make actually, I'm trying to figure out how do I want to explain this. So before we actually make a collection, let me explain why we're doing this. So the idea with resources is that we're going to store them inside of our account, right? So what's going to end up happening, let's change this, is we're going to save some data to the account. Now, without getting too much into the weeds here, if you're truly curious in all of this, I would definitely recommend checking out the Beginner Cadence Bootcamp. So I'll just say that up front. But the idea is that, in a transaction, you can store data to a user's account through the auth account. That's what allows you to do that. And this gets placed here by who is signing the transaction on the right. Okay. So let's say account 2 is signing the transaction. We're going to have access to their account here, which is why it's very dangerous to sign transactions that you don't know what they're doing. But inside of here, we can do signer.save, and we can save some value here, right, to a certain path. So let's say we're storing it to /storage/test. Now, the thing here is, at each storage path, you can only store one thing. Okay. So let's say we were to just have a post and we didn't have a post collection. What would happen is a user would be able to store like some sort of just pretend this is a post one. They would store that to the account storage. And then when they run this transaction again to create another post, it's going to break because they're going to try and store post 2, for example, to the same storage path. And it's going to say, wait a minute, something already exists there. Now, of course, you could then change the storage path by making it a new storage path, but that gets very messy because then you have resources stored at, infinite amounts of locations. Clients and dApps have no idea how to read your account. So it's very bad. But an easy way to solve this is to have a post collection, right? And then every single time you want to create a new post, you simply borrow a reference to the post collection, which will always stay in the same storage path, and then you deposit to the collection resource. So it's one storage path, one resource at that storage path, but you're depositing to that resource. So that's a lot better, and that's actually how the NFT standard is architected. Um, so yeah, that's just an awesome way to solve that problem. So that's what we're going to go ahead and do right now. We're going to create a collection that allows users to post or deposit and withdraw posts from that collection. So let's make a resource here called collection. And we're going to make something called owned posts. So this is all the posts that you have, what did Raven say? Ethereum, Windows, Flow. So we're going to make a dictionary here of all the posts. Now it's going to give us a little error here, missing initializer. So let's go ahead and make an init function and say self.owned posts, arrow, and then an empty dictionary. Now, just for those of you that don't know, this little moving thing, like what does this arrow mean? Usually you would have like an equal sign. However, with resources, you actually need to have a little move operator, we call it. And this is just because in Cadence, one of the things I love about it is that it's very safe and it makes it hard for the developer to really mess up. So, sort of in line with that, it makes you explicitly put a move operator every time you're moving around or setting resources equal to each other um, to make sure that you know that you're actually moving resources around. So we have to put a little move operator here. And of course, because owned post is storing posts, that actually makes owned post a resource just by default, or at least we handle it like a resource by default. So let's make a deposit function here. And then let's also make a withdraw function, right? And inside this deposit function, we're going to actually pass in a post. Boom. The guys at Matrix Market would argue with you. Yeah, that is true. Although that's more capabilities. And the truth is, once anyone gets the capabilities, they have a panic attack. So I don't blame them too much. But if they had taken the beginner cadence course, they would have known. So tisk tisk, guys, take the course. Or the advanced one, by the way, that I finished. I'm super excited to show everyone that. Okay. I get distracted so easily. So where are we in the deposit function? So let's go ahead and deposit a post to our dictionary of posts. No worries, Raven, totally fine. So let's say self.owned posts at token.id, and we're going to force move the post into the dictionary here. So it's as simple as one line. What this is doing is this dictionary is saying, okay, we're going to map the ID. So we're going to map the ID of a post to the post itself. So in this case, when we pass in a new post, we're going to essentially take the ID of it, pass it in as the key, and then take the value of it and pass it in as the value. Now, this is my favorite symbol in Cadence. It's the best one. It's called a force move operator. Basically, it means that you're taking the resource, you're moving it into the dictionary, and then the force one means if something already exists at that location, then panic and abort the program so that we don't overwrite it. But if nothing exists there, then you can move it in successfully. Now, the thing is that this is actually the way that we've written this code. This will never ever panic because every single post has a unique ID, as we made sure to do right here. So it's impossible for this to ever panic. But just in case, and we also, if we don't put this here, then Cadence will complain. Cool. Now let's go ahead and withdraw, and we're going to pass in a withdraw ID, and we're going to withdraw a post resource. Also, this little @ symbol here, this means a resource. It's like a resource type at least. So let's go ahead and say let post. That's like a keyword. Let's just say let token self.owned post dot remove. The key is going to be the withdraw ID. Okay, and we're then going to return token. Now it's giving us an error here, and actually I'm going to ask some of my Cadence graduates here to explain what this means. Why is it saying mismatch types? We expected a memento.post, but we got a memento.post question mark. I have two questions. First of all, what is the question mark indicating? What word is that representing? And two, how do we fix this? What type is that? A memento.post question mark. And optional. There you go, Raven. Great job, Saint. Falcon, you got it. Awesome. Let's go, everybody. And Saint says, number 2, we need to force unwrap. So that's very true. So the way that we do that, I guess the reason it's giving us an optional is because anytime we index into a dictionary, Cadence doesn't know at compile time if a resource actually exists there. So what it does is it says, okay, if you're removing from a dictionary, there's a full chance that this ID doesn't even exist, and so we're going to actually give you back nil, which means just an empty thing. And an empty nil is definitely not the same thing as a post resource. So we have to handle the case where it is nil. So there's two things here. Either one, we could force unwrap, like Saint said, right? We could put a force unwrap here, and all that basically says is, okay, if nothing exists at that location, we have to essentially just abort the program. Or we could also abort the program, but panic instead, which I always prefer doing. And the reason for that is because we can put a helpful error message in here for why we're panicking. So we are aborting the program because the user is trying to withdraw a non-existent ID from their collection, right? So now instead of going into this code and seeing, sorry, force panicked, it'll now say this whole error message, and then we can obviously go back into the code and know exactly where that came from. So it's very helpful. Okay, so with that being done, we also have to add a destructor for the resource field. So what that essentially is saying is whenever you have nested resources, what that means is you have a resource, which is this, inside of a resource, which is this. We have to add a manual destroyer. So a destroy function is run just like the init function is run anytime a resource is created. The destroy function is run anytime the resource is destroyed or exploded or blown up or whatever you want to say. So what we have to say is, okay, if the collection resource is destroyed, which is why we're inside this function, then we have to destroy own post. So we have to basically tell Cadence what we want to do with the nested resource if the parent resource is destroyed. And now it's fine. Right? So we did a lot so far. We have the post, we have the collection. This is looking really good. Now, I'm gonna ask a question in chat. Who thinks what am I missing? Am I gonna be able to create a collection in a transaction right now? And if not, what do I need to add here? Any takers in the chat? Close, Raven. We're gonna get there. But there's a reason I'm gonna struggle with making new collections right now. What do I need to add? I guess the question is, what do I need to add to this contract to be able to create collections? And also, like, why is it the case that I have to add this function? So Saint, you're almost there. A mint collection. That's like half the question. And then I guess the other part of the question is, why do I have to do this? What about resources is making me do this? Numini stumped. Resources need to be stored. Close. Maybe I'll make a yes or no question. Can resources be created in a transaction? No, they can't. The answer is no. So Lanford, ding, 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 you got that right. So resources cannot be created inside of a transaction. They must be created inside of the contract. So we're going to struggle with trying to create a collection resource inside of a transaction. So we have to add a function here called create collection, or let's just call it create empty collection, that will return a collection resource to our transaction. All right. And also for you beginner cadence noobs, this create keyword is needed anytime we create a new resource. So we have to add the little create keyword. So we have to have this function here, and now we'll be able to call this function inside of a transaction to store our collection. Alrighty. And for now, I think what I'm also going to have us do is I'm also just going to add a public mint function. We're going to change this, of course, but let's just call a new function called mint post. And we're just going to mint a new post that's going to return a post right here. So what we're going to do is say return, create a post. Now our post is going to need a few things. It's going to need all of these things right here. Let's go ahead and add those as arguments. Say title, body, boom. So I just added a function to also mint a post. Now, right now, this is public. We're probably not going to dive too much into access modifiers, which is what public means in this build from scratch series. But again, I really recommend checking out our beginner cadence course. So public means anyone can call these two. So let's go ahead and redeploy. And we have a fresh new contract. So let's make a transaction here. We're going to call this mint post. All right. And this transaction is going to mint a new post and store it inside our collection. So first things first, we definitely should import Memento from OXO1. All right. So basically, we are creating blog NFTs. Exactly. So we're the post represents like the blog, and I guess really what it is we're sort of duplicating or making better mirror, right? So it's allowing people to make blogs, and we're publishing them as NFTs. So Numini, you can definitely check this out if you want some more info on what we're building. Cool. So this is the transaction we want. Now, what is the first thing a user will have to have in their account before being able to create posts? And spoiler alert, we actually just worked on it for a while. So what does a user need? Yeah, they need a collection, right? So let's go ahead and give the user a collection. Let's say signer.save memento dot create empty collection, right? We just wrote that function to create a new collection. And we're going to store it to slash storage slash memento collection. Okay, boom. So simple. We just stored a memento collection to the user's account. Now, what do we want to do next? We want to mint a post, right? So let's say let post, or let I don't know, let's say let blog, and this is going to be memento dot create or mint post. Now we have to pass in some data here, which is kind of interesting. But we're going to pass in a title, right? We want the user to type in a title, a body, string, and then I'm gonna hard code these two values for now because we're gonna talk about the problem with these a lot later. But let's just basically what I'm saying by hard code is let's put some values here that are gonna make the cadence errors go away, but that we're eventually gonna change a lot. Okay, so ignore these two for now. We're just gonna pass in the title and body. And what we're going to do is, now that we created our new blog, we need to now get a reference to our collection, and then call the deposit function to our collection. So let's say let collection equals signer.borrow. Okay, borrow a reference memento.collection from the slash storage slash memento collection path. Okay, now what is a reference, right? Inside of our contract code, there's a lot of weird symbols like this at. What is this symbol? Ampersand? No, it's not ampersand. What is this symbol called? Ampersand is this one, isn't it?
Yeah,
And what's this at
that's
symbol?
the. I think so.
I don't even know what it's called. I don't even have any idea what it's called. Sneak.
Let's see.
At. In Russian, we call it dog. Oh, interesting. I think it's just
Oh,
at, right?
oh, wait, hold on a second. The at symbol is correctly referred to as an aspersand. So,
Aspersand.
sorry, no, sorry, aspirand, aspirand. So, this is aspirand, and this is ampersand, just to make it a little
Ah,
bit more confusing.
ampersand. Okay, cool. All right, so aspirand and ampersand.
Now, the source of this information is a random comment on a Guardian article. So, let, let me look up. Um, no, I think it's called at.
Oh,
I
at,
don't know.
yeah, who knows? But anyways, the point is that yeah, at sign. Okay, so there's a lot of weird symbols in Cadence, right? The at sign means a resource, right? That's like a whole object asset that we talked about. But this symbol, the ampersand, which I thought was I always thought it was ampersand, but it's ampersand apparently. So
Ampersand, yeah.
yeah, so the ampersand here, okay, this means a reference. So what does a reference mean? Well, essentially, a reference means we can, you know, we can read data, we can call things on a object without actually needing the object itself. So it's almost like a little clone that we can, access without having to move the resource around. And the reason that, the need for this stems from the fact that if we wanted to access, right, this collection without references, we would have to move the collection out of our storage, call deposit, and then move it back into our storage, right? Because we need to move resources around. That would stink, right? If we had to move our whole collection out of storage, deposit back into storage. So what a reference allows us to do is keep the collection in our storage, but simply get get access to it, right? And that's what the reference is doing. Okay, so that's that. And as I've said 100 times, check out the course; it'll explain all this. Okay, so let's now call collection.deposit. Oh, slight problem here. Just like we were talking about before with dictionaries and optionals, same thing with account storage. So we don't, Cadence doesn't know a compile time if this is actually going to, if a collection actually exists here, because we could type in like poop, and Cadence doesn't know that it doesn't actually exist there. Of course, we do as human beings, but we have to add a little panic here that just says, oops, nothing, or more specifically, a memento collection. A memento collection, let me space this, does not exist at this storage path. So this will either panic for two reasons. Okay, so this will panic for one of two reasons. Either one, nothing exists at that storage path, or two, the thing at that storage path isn't a memento.collection type. Okay, cool. So now we can call collection.deposit and pass in our token, which is just simply our blog. And remember, don't forget the move operator when we're dealing with resources. And that should be it. Okay, so let's try it out. Let's type in a title of 10 ways to deposit Jacob money. This is an article teaching you how to do a good deed. Send. All right, look at that. Nice playground. Account 2 updated the storage in account 02. Okay, that just means that we, updated this account. So now if we go into script, I'm just realizing that I haven't coded enough in the contract to make this fully work yet. So, I haven't added any functions inside of our collection to allow us to read the IDs or even the posts that exist inside of here. So let's make a function in our collection called getIDs that simply returns an array of all the IDs that exist in our resource. So return self.ownedPosts.keys. Right, so this is going to return all the IDs. Now let's make another function called public function with or borrow NFT or borrow post that returns a reference to a post. Return a reference self.ownedPosts at let's call this ID. Let's pass in an ID we want to read from. Self.ownedPosts at a specific ID, and we're going to make sure the reference is a post like this. Okay. Cool. So we added two functions. One to get all the IDs of all the posts that we have, and another function to get a reference so that we can read information of one of the posts that exists in our collection by passing in an ID. Okay. So let's go ahead and deploy. Boom. Let's go ahead and mint another post. Title is going to be Raven is cool. Why Raven is cool. Send it. Also, the reason this, remember I told you before that you can't store multiple things at the same storage path? This would be an error. Like if I run this again, look, it's going to be an error. See, the reason it wasn't an error there is because on the playground, when you redeploy your contracts, it resets all storage. So just a little tip, trick. Okay, we minted an NFT. Now let's go to a script and let's call this read post. So let's return an array of IDs, and we're actually going to borrow some code here. Oh, I actually just realized I made a mistake too. So what's going to happen now is inside of our script function, we're going to want to pass in a address, right? The user that we want to read from. So we're going to pass in an address, and we're going to read all of their IDs that exist in their collection, right? So the idea is that how you read data from someone's account is you first need to get their public account. So let public account equals get account user. This will get their public account, and then we can say, let's get the collection from public account dot, and then this is where the problem is you can't borrow from storage with a public account, because if you could, then I could just withdraw all your assets, right? So we need to somehow have our memento collection available at a public root. And the way you do that is when you're creating, right? This line is creating and storing a memento collection. We need to also do something called linking. Signer.link. And this will allow us to link this type to the public. Let's do that now. Let's store it to /public/memento collection. And because it's a link, we're linking it from the storage path. All right. So let's go ahead. Let's redeploy the contract to just reset account storage. And let's mint a post. Let's call the title Raven. Why Raven is cool. Send it. All right. We have a post now. And if we go back to here, we can now do something called get capability from the public path where we're allowed to read from. Then we can .borrow the collection, panic if it doesn't exist, and then we can return collection.getIDs. Going a bit fast here because we only have 5 minutes left, but hopefully that makes sense. If you have any questions about this, as always, just let me know. So let's read from, how do we sign this transaction with account 2. So account 2 should be the one that has the collection and also the post. So if we were to run this with account 1, you'll see we'll get an error here, right? A memento collection does not exist, but if we did this from account 2, look, we get an array of all the values. So here we go, 39. That's the ID of the post that was created. So let's run one more transaction called, or this should be called, I guess, read IDs. And this one we'll call read post. Read post. Now we can actually take a lot of this code, paste it in here, and we're going to pass in a user and an ID. And then what we're going to do instead is say collection.borrow post with the ID, and the return type now is a memento post optional. Okay, so instead of returning an array of all the IDs, which we did with get IDs function, we're going to now call the borrow post function with an ID that returns a reference to a post. So let's do user 2, and we know the ID is 39 because we just read it. So let's execute, and we get a whole list of data of that post. So the UUID is 39, the ID is 39, the title is Raven, the body is why Raven is cool, is published false, original owner, we've hard-coded an address, and then author is an empty array. All right? Pretty cool stuff. Now, we have one problem here, and the problem that currently exists is, and I guess this is the last thing we'll touch on before next time, is inside of our collection, we have all these functions, right? And when we're minting a post, we're linking, right? When you link a type to a public root, you're basically telling Cadence what type you want to link. Now, in this case, we're linking the entire collection, right? Memento.collection. And the problem with this is that because we linked the whole collection to the public path, anyone can access all the functions inside this resource. We want, oh, and it's back. Okay, welcome back if OBS just glitched. But we're going to put only the functions we want to be public inside this resource interface. So we want deposit to be public because we don't care if people deposit, or maybe we do, but we'll decide this later, right? Actually, maybe we don't want it to be public, right? We have to think about that for a second because we might not want people to deposit posts to our collection. In fact, we don't want people to do that, right? We definitely don't. But because the NFT standard, just stick with me. We're going to also put get IDs and borrow post. So the only one we're not going to put in here is withdraw, just so people can't withdraw from our collection. And we're going to force our collection to implement it. It's all fine. So we can redeploy. And now the benefit of this is that when we're linking this to the public, we're only going to link the collection public type. So what this means is that anyone that tries to read from the public root is only going to be able to access the functions that are of this type. And because the type is now restricted to the resource interface, they can't call withdraw anymore. So this transaction is now fixed. All right. So there's a lot more things to do here. We need to, make this implement the NFT standard and do all that kind of stuff. But I think for now this might be a good stopping point. So maybe I guess Andrea, maybe next session we spend like another 30 minutes on cadence and then we can keep going or
Yeah,
something. Okay, cool.
yeah, for sure. We can spend 30 minutes or 20 minutes on cadence. And then once we kind of have a rough shape of what the contract needs to do, we can start looking at how we want to. Actually, we have two choices. Either we start creating the foundational transactions that we're going to need, right? And make sure that they're all working, and then start fleshing them out in terms of routes and NFCL commands, or we just jump more to the layout. Depends if we want to work cadence and backwards from the cadence, or if we want to work in parallel and meet halfway in future episodes.
Yeah, I totally agree with you. I think first we'll get like a like transactions just that we know kind of like what we can call.
Right, right.
Yeah, exactly.
Yeah,
Okay,
because
cool.
it'll also give us information on, what type of information we need to display, um, what kind of layout we need to create for that information. So not to say that the contract will be, 100% complete. We're obviously going to keep updating on both sides, but I think, yeah, let's do cadence, transactions, and scripts, or like at least the foundational ones, and then we can dedicate some time to creating the full loop. And once we have the full loop going, it's going to be really easy to start adding features.
Exactly. Okay, perfect. Cool.
All right,
So we'll stop
sweet.
there. Thanks everyone for tuning in. I hope you had a good time, and we'll see you next. Oh, we'll make an announcement about it because I know next week of the holidays, so we might take a break next week, right? But
Yeah, yeah,
yeah.
we might we might take a break. Uh, but yeah, let's chat about it, and we can post an announcement whether we whether we take a couple weeks break, because I for sure won't be available the following Tuesday, the one after next week.
Okay.
I don't know if you're available, but maybe we take a 2 week break and then we pick things up again.
Got it.
How about that?
Got it. So yeah, we'll make an announcement, guys. Just don't worry about it. Just focus on the intercom channel in this Discord. And if we
Yeah,
don't see you for a couple weeks, I hope you have a lovely, lovely holiday season. Whether you're celebrating Hanukkah, Christmas, New Year's, whatever it is you're celebrating. Hope you're having a great time with family and friends. So thanks everyone for tuning in. Um, don't forget we have developer office hours also on Thursday. So if you have any questions about cadence or anything you're building, see you there. But thanks everybody. Happy holidays.